Okay, having a look at some questions for grade 8 maths in term 4. So what I've got is a few weekly tasks. They go through the same types of questions, but give some extra practice on these topics. Obviously the questions on the second half are going to be taught later in the term, so you may find that some of the topics you haven't learnt yet, but it's good to have a go and see some of those in advance. So the first one we've got is perimeter, and we want to complete this diagram on how we would be able to convert the units for perimeter. So if we're going from kilometres to metres, we are multiplying by 1,000. When we're going from metres to centimetres, we are multiplying by 100. When we're going from centimetres to millimetres, we're multiplying by 10. Then if we're going the other way, millimetres to centimetres, we're going to divide by 10. Centimetres to metres, we're going to divide by 100. And metres to kilometres, we're going to divide by 1,000. That means we can then have a go at these questions here. So we've got a converting 100 millimetres to centimetres. So we know if we're going millimetres to centimetres, we're going to divide by 10. So that means our answer is going to be 18 centimetres. When we're going from centimetres to millimetres, we're going to multiply by 10. So that means we're going to get 167 millimetres. If we're going from metres to centimetres, we're going to be multiplying by 100. So that means we're going to get 940 centimetres. Here we've got how can you find the circumference of a circle. Now there's two ways. You might have learnt C equals 2 pi r, or you might have learnt C equals pi d, and where d is the diameter and r is the radius. I prefer the C equals pi d because that means you're not going to get confused with the area of a circle, which is pi r squared. Here we're looking at finding the perimeter of the following. So we've got this shape here where we know that we have these two sides are 3 centimetres. We don't know this one here, but we do know the whole length is 8. This part is 3, so that part up there must be 5. So when we're doing our perimeter, we're writing sum of sides. And so we can then just go around our shape and add them up. So we've got 8 plus 7 plus 5 plus 4 plus 3 plus 3. So we get 30. The other way that we could have done it is we can make that shape one big rectangle by folding that 4 up there and the 3 up there. The 3 can come up here and the 4 can go over there. So we get the 8 by 7, 8 by 7, or we can just add them up individually. Then we've got our circle here. So we know when we're talking about perimeter of a circle, it's the circumference of the circle. And I like to use pi times diameter. My diameter here is 16 centimetres, so I've got pi times 16. So I'm going to do my pi times 16, and I get 50.265. So I'm going to round that to 50.27 centimetres. I'll round to 2 decimal places. Here we've got our diagram for converting area units. So instead of having just kilometres, metres, centimetres like we had at the top, we've got kilometres squared, metres squared, centimetres squared, and millimetres squared. So when we go from kilometres to metres, we would have multiplied by 1,000 if it was just kilometres to metres, but because it's squared, it's 1,000 squared. So then if we're going back the other way, we're dividing by 1,000 squared, and we could write that as divided by 1,000,000 if we wanted to write it out in full. Otherwise you can just use the square button on your calculator. Metres squared to centimetres squared, we're multiplying by 100 squared and multiplying by 10 squared. Again, if you want to write it out in full, that means you would be multiplying by 10,000, divided by on the bottom, and dividing by 100 there when you do the 10 squared or the 100 squared. So when we're converting these units, we've got 680,000 metres squared. We want to go to kilometres squared, so we're dividing by 1,000,000. So we're going to do our 680 divided by, and we could do that 1,000 and use the squared button on the calculator and do it that way, and we get the 0.68 and that's kilometres squared. Then when we're going centimetres squared to metres squared, that's where we're dividing by 100 squared, or we can do divide by 10,000. So we will get 0.5 metres squared when we do that. Question 7, we're stating the rule for the areas of the shape. So circle, our area is equal to pi r squared. Parallelogram, our area is equal to base times height. Trapezium, our area is equal to a half of a plus b times height. And our rhombus is a half xy. Now you could be given these in the exam. My class, at our school, we give our rule sheet in the exam, so we will have the rules to look at from the formula sheet. Now here we've got finding the area. Here we've got our rhombus, so it is going to be a half xy. So it's a half times 5 times 7, because the x and the y are just those internal dimensions on the shape. So from one side to the other, and from top to bottom of the shape, those inside ones. And so when we do that, we've got our 5 times 7, and we're doing half of that. And so we get 17.5, and that is meters squared. Then we've got our trapezium, so we've got a half of a plus b times height. In this case, our a and b are these top and bottom numbers. On the diagram, you should generally have for parallelogram those parallel lines marked on there, and they're the two that you're going to add together. So we've got a half of 3 plus 6, and we're multiplying that by 2. So effectively the half and the 2 would cancel out. 3 plus 6 is 9, but you can do it all together if you want. And that gives us centimetres squared. Then the last one we've got is an area of a circle. Now we know that area is pi r squared, but we've got the 8 here, that's our diameter. So we know that the radius is going to be half of that, which is 4. So we've got pi times 4 squared. And that gives us 50.265, which we can round to 50.27 metres squared. Okay, on to the second side, we've got some volume conversions. So when we're looking at our volume, 1,000 millilitres, that's equal to 1 litre. 1,000 litres is going to be 1 kilolitre. Then we've got 1,000 kilolitres is the same as 1 megalitre. 1 centimetre cubed is the same as 1 millilitre. And 1 metre cubed is the same as 1 kilolitre. So they're ones that you'll have to know. You won't be told those in an exam. Same with our unit, with our area unit or perimeter unit conversion diagrams, you'll need to know them as well. Here we've got finding the surface area and the volume for the following shape. So I'm going to do my volume in blue and then my surface area in black. So my volume for this one is just going to be length times width times height, because my volume is area of base times height, and the area of the base is length times width. Now we happen to have a square base, so we could have written side times side. We've got 3 times 3 times 7, so that is going to give us 63 metres cubed. Now when I do my surface area is where I'm doing each of the faces. So I know I've got 2 of the top, I've got a bottom and a top, they're the same, and then I've got the 4 sides. And because it's a square, they're all the same as well. So we sometimes see our rule as 2 lots of length width plus 2 width height plus 2 length height. So we've got 2 times 3 times 3 plus 2 times 3 times 7 plus 2 times 3 times 7. So when we do that, our 2 times 3 times 3 gives us 18. And then 2 times 3 times 7 gives us 42. And then we've got another 42 there. So when we add that up, we get 102, and that is meters squared. Then for our cylinder, so for our volume of our cylinder, we know that it's area of base times height. So that means it's going to be pi r squared times height. So here our radius is 5, so pi times 5 squared times 11. And we get 863.94, and that will be meters cubed. Then for our surface area of a cylinder, we know that it's 2 pi r squared plus 2 pi r h. So the 2 pi r squared is the top and the bottom, there, the two circles. And then the 2 pi r h gives us that area that wraps around the cylinder. So we've got 2 times pi times 5 squared plus 2 times pi times 5 times 11. So we get 157.08 plus 345.58. When we add them together, we get 502.65, and that will be meters squared. Or that will round to 66, sorry. Then we get on to some little facts about time that we need to know. So there are 60 seconds in a minute, there are 60 minutes in an hour, there are 24 hours in a day, 7 days in a week, 52 weeks in a year, and 12 months in a year. Then we've got a little converting a time to 24-hour time. So we've got 9:30 p.m. So with 24-hour time, we're effectively adding a 12 to this number here. So the 9 we're going to add 12 to, and that gives us 21. And then we write that 30 there. We don't put any dots in, and we put a H on the end. If it had been AM, we would have kept that first number as it was. So if that had been 9:30 AM, we would have written that as 0930 hours. Then we've got a little bit on congruency. So the codes for congruent triangles. We have our SSS, which means the sides are the same. They have a matching side on each of the triangles. Then we've got side, angle, side. So you've got two matching sides and a matching angle. We've got angle, angle, side. So two matching angles and a side. And then we have RHS, which means we've got a right angle, the hypotenuse, and a side that matches. For our parallel lines, when we're looking at the angles in parallel lines, we've got the F rule, where we've got corresponding angles are the same. We've got the U rule, where it's co-interior angles add to 180. And we have the Z rule, where alternate angles are the same. In number 13, we're looking at which ones are congruent and giving a coded reason. So looking at these ones, we've got 11 and 12 on each of the shapes. We've got 70, 60, and 70. So we're looking at these two here as the congruent triangles because they've got the same sides and the same angle there. Because we've got two of the same sides and an angle, that means we can say the coded reason is SAS, and we can write the congruency statement. So we're saying that triangle ABC, so we're a little triangle, ABC, we use the three lines to say that it's congruent, and then we're saying that it's congruent to GHI, and we need to make sure we label in the same order as it corresponds to GHI, and I should put my triangle in front there. Now the last two questions are using Pythagoras' theorem. So we're finding first the hypotenuse in this one, and then one of the shorter sides here. So we're going to write our c squared equals a squared plus b squared. So then we can say x squared is equal to 8 squared plus 7 squared. So 64 plus 49. And that gives us 113. So our x is going to be the square root of 113. And we can work that out on our calculator as 10.63, and that will be meters. Now with our second one, we're finding a shorter side, so we still start the same way. C squared equals a squared plus b squared. Now I should have labelled my a and b here, so I used that as my a and b. Here I've got my c, I'm going to write a and b there to make sure I match them up. So I've got 5 squared is going to equal x squared plus 4 squared. So my 5 squared is 25, x squared plus 16. So I'm going to take that 16 over and do 25 take 16. That's going to give me 9. So then my x will be equal to the square root of 9, which is 3. And we call this one a golden ratio triangle with the 3, 4, 5 as the sides. So any ones that have factors of that golden ratio are ones that we call the golden ratio triangles. Okay.